So welcome to this segment as we further continue looking at arrangement of electrons in an atom. Remember, like I said, if you're looking at the elements starting from hydrogen, if you're looking at elements starting from hydrogen with proton number 1 all the way, to calcium with proton number 20, I did say in the first shell or the first energy level, the first shell, you can accommodate 2 electrons. In the second shell, you can also accommodate 8 electrons. In the third shell, it can also accommodate 8 electrons. So that is what I did mention. That is for the first 20 elements of the periodic table. But suppose I go beyond maybe an element with bigger proton number. What am I going to do? How can I write my electronic arrangement? Well, it is very simple. If you want to know the formula that we use, so there's a formula that we apply to know the maximum number of electrons in an energy level. So if you want to know the maximum number of electrons that can be occupied in a shell, we use the formula 2n raised to the power 2, where in this case n is the position of a shell. So we call it as being the position of a shell. So in simple terms, I can say if you want to know the max of electrons there, it is 2n raised to the power 2. And this is the formula that we apply if you want to know that. Now quickly, I want to tell you, in this case, you can have, the first shell, the second shell, the third shell. Let me just start with from there. So this one, the innermost one, this is when n is equal to 1. This one is when n is equal to 2. This one there is when n is equal to 3. And that one is when n is equal to 4. So you can go on, so on and so forth. So normally they are given letters. As you learn or read in some books, you are going to find that there are letters that are given. For example, the innermost is called K, L, then followed by M, N. Then we follow just the alphabetical order. So when K is when n is equal to 1, L is when n is equal to 2, M is when n is equal to 3. So these are representing the energy levels, the position of a shell, or if you want, you can simply say the position of the energy level. For example, if my n is equal to 1, what is the maximum number of electrons that would be occupied? It would actually be 2 multiplied by 1 raised to the power 2. 1 raised to the power 2 is 1 times 2, give you 2 electrons. So meaning in the first shell, it can only accommodate 2 electrons. What about when my n is equal to 2? What's the maximum number of electrons that I can have? Again, it will be 2. You substitute your n for 2, 2 raised to the power 2. 2 raised to the power 2 is a 4. 4 times 2 will give you 8 electrons. So you are able to see the I. So the second shell can occupy a maximum of 8 electrons, just like I said. But remember here I said, for the third shell there, that 8 does not mean it's the maximum. The maximum is actually 18 electrons. But for the first 20 elements, that can still stand. It is okay. Now let's see, in this case, when my n is equal to 3. I'll just clear up this space so that I can create more. When my n is equal to 3, then what is the maximum number of electrons? So remember, 2 n raised to the power 2, it will be 2, 3 raised to the power 2. 3 raised to the power 2 is a 9. 9 times 2 will give me 18 electrons. So you can see that in the third shell, the maximum that can be occupied is actually 18. So meaning when you want to write the electronic arrangement for bigger proton numbers, the maximum should occupy 18 electrons. Let me just show you that. For example, they tell us to say, write the electronic, so write the electronic configuration. So write the electronic configuration of the following atoms. A, they give you selenium, a very common one. Selenium is an element found on the periodic table, and selenium has the symbol capital S and small e, and it has got proton number 34 and 79. Then B, the other one that I'm actually going to use is let me say germanium. So I'm going to use, you know, germanium, which is actually Ge, and it has got proton number 32 and the nucleon number 73. Right, and we want to write the electronic configuration. So you don't need to worry about that much. No, this is very simple. In this case, if I look at selenium Se and 34, it has got 34 protons, meaning that there are 34 electrons that are there. So let's use those electrons to write the electronic configuration. Remember, we are looking at, we use the electron. So in the first shell, I'm going to put up 2 electrons. So those are 2 electrons. Then in the second shell, I can put up 8. 2 plus 8, that is 10. You still have a lot out of 34. So meaning you can add, now in the third shell, the maximum is what? 18. So you can add those 18 electrons there. So 2 plus 8 plus 18, we are now at 28. How many are remaining to make 34? There are 6 that are remaining to make 34. So those 6, I'll write them like that. So this is the electronic configuration or arrangement of selenium. And if I was to ask you, in which group of the periodic table does selenium belong to, and which period does it belong to? So the group, you look at the number of electrons in the outermost shell. It is simply 6. It is found in group 6 because it has got 6 electrons in the outermost shell. And the period, how many shells have been filled with electron? 1, 2. This is the first shell, mind you. This is the second shell. This is the third shell. And this is the fourth shell. So there are 4 shells that have been filled up with electrons. So therefore, it is found in period 4. So that's the way you can do it. When the proton number is bigger, you need to apply the concept that the third shell can occupy up to 18 electrons. Let's look at our last one there. Germanium, in this case Ge, which is 32 and 72. But of course, we use that the number of protons is 32, meaning the number of electrons will be 32. So the electronic configuration will be in the first shell, yes, 2, then 8. I still have more. I can't just put up 8 there. I can accommodate 18 in the third, which is the maximum. So that will give me 28. And if you look at how many are remaining to make 32, it is simply 4. All right? I hope you are getting it. In which group does this belong to? It is simply group 4 because it has got 4 electrons in the outermost shell. In which period does it belong to? It actually 1, 2, 3, 4, period 4 as well. For the love of chemistry, let's continue to practice so that you can actually get to learn more. Please watch out for my other videos. I'll teach you about, a formation of what we call as spin ions. Thank you so much for watching.